Hey guys, this is James Boyer with Coding Casserole, and we are doing another video in our coding interview question series, again on the beginner difficulty. And fun fact, this is actually a question that my company used in our interviews this year for interns. So, at least one company is out there using this problem. And so let's jump into it. The question asks, write a function that solves if two words are anagrams of each other. And that's a fancy way of saying, can you rearrange the letters from one word to spell the other word? We give a couple examples, and then we kind of just don't say anything else. So I like to take a step back when I am first asked in an interview question and try and think about the edge cases or the input and ask the interviewer back some questions. Again, this is two reasons for doing this. One, you show the interviewer that you're critically thinking and looking ahead, which is always good during an interview. And second of all, you are saving yourself the pain of when you're in the middle of writing your answer and you realize that there's an edge case you didn't consider, or the interviewer tells you that there's an edge case and you have to kind of on the fly reorganize your code and rewrite it. It's not very fun, and for me, it can get a little nerve-wracking when you have to do that. So try to avoid as much as possible. So for example, in these types of questions, maybe an example of question you could ask back to the interviewer is if case sensitivity matters. For example, is a capital C the same as lowercase c? And will there be spaces in the words? And so let's say you ask those questions and the interviewer tells you that your function that you write should be case sensitive, and let's say it should account for white space. So it's good. You know those two answers now, and you won't have to really worry about them when you are writing the code, as you've already thought about them. Now, as always, I'm going to stop and give you a chance to pause the video, and there will be links down below, and you can clone this and try it out yourself. And then you can come back, and if not, then just keep watching the video. So the way that I approach this problem is I thought about how I would solve it as a person and then look for the overarching pattern in it. So for example, when you have race car and you have the word fire truck. So the first thing I would do as a person is I would go through and I would see that there's an R and I would cross it off. And then I would see if there's an R in fire truck and I find one and I would cross it off. And then I would go to A and I would cross it off and I would see if there's an A in fire truck. Now, there's no A in fire truck, so I know that I can stop here. There is no A, so there's no way for us to rearrange the words. They're not anagrams. Now, if I had gone through and crossed off all the letters of race car, and then I looked over and all the letters of fire truck were crossed off, I would know that these words were anagrams. So what that shows me is at the bottom level, all we really need to do are comparisons of letters to letters. Now, obviously, walking through each letter and each word is painfully slow as a person. So, the way to think about how that would be quicker, well, if all the letters were in order. Because you now know if all the letters were in order, you would only have to compare letters until you found letters that weren't the same. So, for example, in race car and fire truck here, race car is like A, C, C, E, RR, and then for fire truck, it's going to be a doozy here. We've got C, E, F, well, and then some other letters, but it doesn't even really matter because as you see, now that the letters are in order, you can just go through, cross off the A, and as soon as you see that there's an A is not at the first letter here, you know that these words are don't have the same number of letters and don't have the same, or at least have one of the following reasons that they don't have the same number of letters or they don't have the same letters. And so you can go ahead and stop comparison. So again, just to recap, we figured out that everything was comparison based, and then we figured out that to do comparisons quicker, it would help if everything was in order. So sorting the words is one way of doing it. Now, I will say that this is the logic that I took when I was first asked this question, and it is not actually the most optimal way of doing it time complexity wise, because sorting is in log n, which if you don't know what that means, it just means that the time complexity is scaling by the logarithmic times the value of the word. So basically, as the words get longer with more letters, you are going to solve this problem slower and slower. Now, there is actually a faster way of doing it, and I will include that in the anagrams _ solved.py file. That will be on the Git link below, but that will be for a video on a different time, as we're just going to cover this way of doing it, which is the actual way that I did it when I first did the problem. So let's go over here and let's go ahead and open up. This is how your file should look when you first get it. And go ahead and take this line out. So we have the first constraint they gave us was that white space might come in. So in Python, all we need to do to get rid of white space is we're going to say we want to replace all of the white space with no space. And so again, Python is a great language for doing interview questions, because the standard library that Python has by default has a ton of functionality built into it. Now, we also know that case sensitivity matters, so we don't have to strip all the words to lowercase. But if they had said, case sensitivity doesn't matter, this is where you would want to make all the letters lowercase. So again, as for the comparison's sake, we know it's faster if we sort the letters. So sorted is another Python function. So we can go ahead here and do that. And now we know if x does not equal y here, then we can return false, and else we can return true. So again, all we're doing here is the process we talked about earlier. So given the two words, we sort them, and then we just tell the computer to check and see if they're the same. So let's go ahead and hey guys, sorry about that. I actually had not written the test case yet, so I went ahead and paused the video to save you guys some time on your life, and went ahead and wrote it. So again, where we left off here was we had written anagrams py, and we were going to run it against our test function here, make sure everything works, and as you can see, cat and cattle fails, which is good. Cat and cat fails. Cat and nothing fails, and then listen and silent returns true, which is what we want, and then dormitory and dirty room fails. So and that's probably because of the capital D and the lowercase d. So that's pretty much it for the video. Let me know if you guys have any questions about this problem. Again, there is a better way of doing this that will be in the anagrams solved file, but I encourage you to try and think about it and see if you can come up with it yourself. And if there are any questions that you guys want to see done in the future, please drop me a note and let me know. All right, have a good time, and until next time.